Hi there, this is Robin Andrews from CompuAcademy, and this is another video on SQLite. This time we're going to be talking about how to use Python to interact with an SQLite database. Now this comes up in various exam boards for GCSE and A-level. For example, in the OCR GCSE Computer Science syllabus, you can see here they want you to use SQL to search for data. Okay, so for the purposes of this video and also your own work on this topic, I recommend that you download this piece of software, DB Browser for SQLite. It's a GUI, that's a graphical user interface, for interacting with an SQLite database. So if you go to Downloads, after having searched for it on Google, for example, then you just want to choose the right installer for your system. So either a 32-bit or 64-bit version for Windows, or they have it for Mac, and they have it for Linux as well. Okay, so here's the actual Python code we're going to be working with. I'm going to take you through this more or less line by line and explain what each part does. Okay, so first of all, we have to import SQLite 3. That's the latest package for interacting with an SQLite database in Python. Then this line creates a connection. So we have a variable called con, which is short for connection, and it connects with a database in the same folder that this program is being run from, okay? And if that database doesn't already exist, it will in fact create that in the folder that you're in. Okay, the next line, we have C equals con.cursor. So that means create a cursor for the connection that we've just created. Now, don't worry too much if this seems a little bit complex. A cursor is really just a way of writing and reading from the database. You can think of it maybe like a pointer that's pointing to the current location in the database, and it moves through or iterates through the records in the database. And it's just a way of keeping track of where you are. So even if that seems a little bit complex and confusing, just go with it and it will all become clear later on, okay? So then using this cursor now, we can then execute various SQL commands. So it's worth being aware that this program is actually making use of knowledge of SQL, which is a language in its own right, as well as knowledge of Python. And we're bringing those two together. So this could be quite complex if you're not that familiar with either of those languages. But just be aware that they're both going on at once. So this drop table, if exists, topics, is actually an SQL statement that's embedded within a Python statement. Okay, so just be aware of that distinction. So this line here, c.execute. Now, executing code means running it. So it means using our cursor, right, which we've created with this line, using that cursor, execute this SQL here in the green. Okay, so drop table if exists. Now you've got to be careful when you're dropping tables from code, because if you have some data that you ever wanted to keep and you dropped the table, it would disappear and you would lose your data. So just be aware that in this very simple situation, a demonstration, I don't mind losing my data, but if it had some important data in it, I wouldn't want to be dropping it without making a backup. Okay, so just be careful when you're dropping tables. And then I'm just doing that to make sure it doesn't already exist, okay, that table within our database. Remember, our database is called demo.db, okay. Then I'm executing this command here. Now, in order to be able to execute a multi-line command, which is basically a string, yeah, all this SQL is within Python, it's treated as a string, I have to have these triple quotations, okay. This is how we do multi-line strings in Python. We have triple quotations. It can be double. But either way, you need single or double, triple quotes to have many lines within a string. Okay, so I'm going to talk you through this SQL now. We're creating a table, and it's called topics. Okay, and then we're giving it some fields. Okay, so the first field is ID, which is of the type integer, and it is the primary key. Now, we've probably talked about this before in the previous video. Every table needs to have a primary key. That's a way of uniquely identifying each record within the table, okay? And I've set it to auto increment. So that means whenever we add a new record, that's a new row to this table, it will be assigned automatically an ID, and that ID will be treated as the primary key, okay? So that's what this line does. Then we have a field called topic name of type text, and it's not allowed to be empty. That's what not null means, okay? And then we have syllabus reference, which again is of type text, which basically just means string, and again, it's not allowed to be null, so it can't be empty. Okay, so you've probably worked out by now that we're doing something to do with topics and references. So what I've done is I've put in the main topics from the OCR GCSE syllabus and their references, just as a, a kind of meaningful example to work with databases. Okay, so we have this function here, insert topic, which we're calling down here, for example, with systems architecture 1.1. So topic will be systems architecture and the reference will be 1.1. And then this syntax here with con, this is just a way of making sure you don't have to remember to close the connection yourself. Okay, this is very Pythonic. In other languages, you might have to explicitly close the connection that you've made. But don't worry about it for now. We're not focusing so much on the details of file handling in Python at the moment, so just go with it. With. So with con, c.execute insert into topics, topic name, syllabus reference. This is how you use SQL to insert into a table. Okay, so you insert into, and then the name of the table, and then the fields within that table, okay, that you want to insert the data into, wrapped in brackets, then the values. Now I've used this dot format. There are other ways of doing this. You could actually close off the string and then use string concatenation using the plus sign, but that gets really fiddly. And so it's well worth knowing about dot format, which does something that we call string interpolation instead. So basically it interpolates these values into these placeholders here. So yeah, we're interpolating, so basically putting these values into these placeholders, so that in fact when we do this first function call, it's going to interpolate or substitute systems architecture into this first one and 1.1 into this second one, okay? And then it's just executing it, yeah? So it's executing this SQL command. So that's going to insert our data into the database. And you can see we do that 3 times. So we insert memory with syllabus reference 1.2 and storage with syllabus reference 1.3, okay? And that's how we're inserting data into our database using a Python function. And then we have another function for getting the topic by reference. Okay, so we're calling that down here, get topic by reference. So we want to find what topic name comes with reference number 1.1. So we're querying our database. Okay, so again, we're using C, which is our cursor. Okay, it's the cursor that's associated with the connection. Okay, and we're executing this SQL here. So select, that's a very important keyword that you absolutely need to know for SQL. And we're selecting topic name, that's the field name. From topics, that's the name of the table. And then we have the conditional. Okay, so we have a condition where syllabus reference is equal to the thing that got passed into the function. So in this case, where the syllabus reference is equal to 1.1, okay? So that's going to execute the query, and then the function actually returns value of c.fetch1, right? So that just means fetch one row. There are other commands such as fetch all and different ways of fetching stuff, but we just want one row, and we actually only want the first item of that row. So return c.fetch1, that means fetch one row, and we want the first item of that row, okay? In this case, there is only going to be one item because we're selecting topic name, but I just put that in there to show you that you can actually access individual parts of that result using indexing like this, like list indexing, okay? So we've looked at these were the function calls, and then printing the result. And then finally, we commit the changes. Okay, so you have to con.commit. That makes sure everything stays. Everything that you've done kind of stays done. And then con.close, that closes off the connection. Okay. So let's see what happens when we run it. Just drag the result onto the same screen. So we've actually done quite a lot, even though it doesn't look like it. We've created a database. Within that database, we've created a table with 3 fields of ID, topic name, and syllabus reference. We've inserted some data into that database, or into that table. Okay, and then we've actually queried that database to find the topic that has reference 1.1, and it tells us here systems architecture. Okay, so that's a fairly basic example, but there's quite a lot going on there. Just get rid of that again. So just quickly go, see if there's any important points that I've missed. We've imported the module, we've created a connection, we've created a cursor. Using that cursor, we've executed some SQL to set up our table. We've created some functions, one that allows us to insert a topic into the database. And we've used this with construct, which is the Pythonic way of doing this kind of stuff. We've used some string interpolation where we've substituted our arguments, or our parameters, into our SQL query. Same sort of thing here for getting our data from the database. We're executing this SQL, interpolating the reference argument, and then returning the result of that, just the first result of any rows that are returned from that SQL query. Okay, and then printing the result of that, committing our changes to the database, and then closing. Okay, so when you've finished running that code, you can then open up your DB browser for SQLite, and you should see that your topics table has been created, along with the fields, ID, topic name, syllabus reference. And then you can browse your data, and this is now set to topics. That's the only table we really have. The other one's just about internal indexing. You can ignore that one. So topics. You can see that, in fact, we have got our IDs. They have been auto-incremented. Okay, this is our primary key, auto-incremented 1, 2, 3. And then we have our systems architecture, memory, storage entries, along with their associated syllabus references. So our code did work, as can be verified by using this piece of software. Okay, so that's it for now. Hopefully that was useful, and we'll see you in the next video. Goodbye for now.